Good morning friends. Now in the previous lecture we started with a pair of linear equation in two variables. We have discussed about the graphical methods of solving a pair of linear equation in two variables, and we also discussed one of the algebraic methods to solve a pair of linear equation in two variables, that was the substitution method. Now in this lecture we are going to move further with the second algebraic method of solving a pair of linear equation in two variables, that is the elimination method. Right, the name itself suggests elimination. Elimination, that means to eliminate. Right, elimination means to eliminate. Eliminate means to remove. Now how to solve this kind of pair of linear equation in two variables, the given pair of linear equation in two variables using the elimination method is, first of all you need to make the coefficients of any one of the variables as same. Right, either x or y. It is not necessary to first of all make the coefficients of x as same, or first of all make the coefficients of y as same. As per the convenience, we are going to make the coefficients of any of the variable as same, and then we shall subtract the first equation from the second, or the second from the first. That means we are going to eliminate the equations. Let me say, for example, if I am having a pair of linear equations here, that is x plus y equals to 5, and the second one is 2x minus 3y equals to 4. Now see, I am having the pair of linear equations here as x plus y equals to 5 and 2x minus 3y equals to 4. Looking at the equations, we can come to know that we are not having any of the coefficients same. That means neither the coefficients of x are same and neither the coefficients of y are same. Right, so what we are going to do first is, we are going to first of all make either of the coefficients same. So let me say that this first equation is my equation number 1 and the second one is my equation number 2. Therefore multiplying equation 1 by 2 and then eliminate them. Right, so what we are going to do, first of all we are going to multiply equation 1 by 2. So if we multiply 1 by 2, we get 2x plus 2y is equal to 10, and the second equation, that is 2x minus 3y equals to 4. So if I want to eliminate them, what I am going to do is I am going to subtract them. Note that when you are going to eliminate these equations, you must subtract in order to take out any one of the coefficients. What you can do, you can subtract, or you must subtract those given equations in order to take out the terms with the same coefficients. That means this 2x and 2x will be removed here. This 2x minus 2x will become 0. 2x plus 3y, sorry 2y plus 3y, that is equals to 5y, and this is 10 minus 4 is equals to 6. Right, so you can say that y is equals to 6 upon 5 here. Is it clear or not? Right, so this is my y is equals to 6 upon 5. Now what we are going to do is, now we are going to substitute this value of y equals to 6 upon 5 in any of these equations 1 or 2. So substitute y is equals to 6 upon 5 in, let us say, equation number 1. What shall we get? We get x plus 6 upon 5 is equals to 5. Therefore x is equals to 5 minus 6 upon 5, that is 25 minus 6 upon 5, and that is 19 upon 5. So this is my x. So the solution to this given equations are, or is, x equals to 19 upon 5 and y is equals to 6 upon 5. Right, so in this way you can get the solution of the equations by using the elimination method. Is it clear everyone? So elimination method, again, elimination means to eliminate either of the variables. Right, either we make the coefficients of x as same, or we make the coefficients of y as same, but don't try to make the coefficients of both the variables same at the same time. that will lead you to nowhere, because both the variables will be cancelled and you will get value of neither of the variables, right? So first of all, what we did here, multiplying the first equation by 2 and eliminate them, we got 2x plus 2y equals to 10 and 2x minus 3y equals to 4, right? So this 2x and 2x will be cancelled. 2y plus 3y, that is 5y equals to 10 minus 4, 6. So we get y equals to 6 by 5. Substituting this value of y in either of these equations, you can either put this value or substitute this value in equation 1, or either you can substitute this value in equation number 2. That will be same, right? So we got x equals to 19 by 5 and y equals to 6 by 5. One more example I am having here is 3x plus 4y equals to 10 and 2x minus 2y is equal to 2. Right, this is the equation I am having here. 3x plus 4y equals to 10 and 2x minus 2y equals to 2. So what we shall do is, the first one is our first equation and second one is our second equation. Multiply 2 by 2 and add them. What we are going to do is add them. See the difference here. We have eliminated here. Elimination, that means to remove, that means to subtract. So we have subtracted here. Now here we are going to add them so that we can eliminate the value or the variable y here, right? So what shall we do is 3x plus 4y equals to 10. The first equation is as it is. In the second equation now we are going to multiply it by 2. So we shall get 4x minus 4y is equal to 4. Now if I add this 4y and 4y will be cancelled. So 3x plus 4x, that is 7x, equals to 10 plus 4, that is 14, and hence we get x is equals to 2. So we got the value of x here, that is x equals to 2. Now substitute x equal to 2 in either of this equation. Let us substitute it in equation number 2. What shall we get is, we get 2 into 2 minus 2y is equal to 2. Therefore 4 minus 2y is equal to 2. Therefore 2y is equal to 2 and hence y is equal to 1. Right, so we got the solution here, x equals to 2 and y is equal to 1. Right, so in this way again you can either add them or you can either subtract them. This is the equations how we can eliminate them. This is the method how we can eliminate the equations and get the solution of the required given pair of equations. Is it clear everyone? Right, so both are the examples of the elimination method. I am having some more examples that you need to try it by yourself. Right? Try it by yourself and try to get the solution of these equations. That is 3x minus 5y minus 4 equal to 0 and 9x is equals to 2y plus 7. And the fourth one is x by 2 plus 2y by 3 is equal to minus 1 and x minus y by 3 is equal to 3. Right. These two examples that I have written here is of the same type, that is the elimination method. Write down the questions and try to solve it by yourself. There are some more examples related to the elimination method and related to the substitution method that we have told in the previous lecture in your new NCERT textbook and also in the exemplar. So you can also take those questions out from those books and you can try to solve it by yourself for the practice. Right? Good. So I think this must be clear here. If it is clear, then we shall solve some more examples related to the elimination method and then we shall move further. Okay. Now let us see one more example related to the data type question here, right? That we are having a fraction becomes 9/11 if 2 is added to both the numerator and the denominator. If 3 is added to both, numerator and denominator, it becomes 5/6. Find it. So it means the fraction. Find the fraction, right? Now, as we are having a fraction here, that is 9/11. It becomes 9/11 if 2 is added to the numerator and denominator. If 3 is added to the numerator and denominator, it becomes 5/6. We need to find out the fraction. So the solution starts. Let the numerator of the fraction be x and let the denominator of the fraction be y. Right, so our required fraction, therefore the required fraction is x upon y. This is our required fraction. So what we shall do is we shall find out the values of x and y, and then we shall substitute it in this fraction, right? We shall find out the values of x and y and we shall substitute it in this fraction. So we shall get our required fraction. Therefore, according to the given information or the given condition, what can we say? That x plus 2 upon y plus 2 is equals to 9/11. See, this is the fraction given to you, x upon y, right? If 2 is added to both numerator and denominator, that is in numerator we are going to add 2, in denominator also we are going to add 2. So if 2 is added in both the numerators and denominator, then we shall get the fraction equals to 9/11, right? And the second condition, if 3 is added to both numerator and denominator, then it becomes 5/6. So first of all solve this. 11 into x plus 2 is equals to 9 into y plus 2. Therefore 11x plus 22 equals to 9y plus 18. Take this 9y and 18 on the left side, we get 11x minus 9y plus 4 equal to 0. So that is our first equation. That leads me to the first equation. And the second condition being, if 3 is added to both the numerator and the denominator, it becomes 5/6, right? So again cross multiplying here, we get 6 into x plus 3 is equals to 5 into y plus 3. Multiplying 6 and 5 inside, that will give me 6x plus 18 equals to 5y plus 15. Taking both the terms 5y plus 15 on the other side, we'll get 6x minus 5y plus 3 is equal to 0. So that is my second equation, right? Now take a look over here, the coefficients of x and y here. are not same. So first of all, what we are going to do, we are going to make them same, right? So multiplying equation 1 by 6 and equation 2 by 11 and then eliminate them. First of all, let us multiply the first equation by 6. So if I multiply here by 6, I shall get 66x minus 9 into 6 54y plus 4 into 6 24 is equal to 0. And in the second equation I am going to multiply it by 11. So I get 66x minus 5 into 11 55y plus 33 equal to 0. That is minus plus minus. Now if you notice here that none of the coefficients was 0 or 1 or anything, both the equations possess the coefficients of the variables as totally different ones. So in this case we need to multiply by vice versa. That means if we want to make the coefficients of x as same, right, then first of all look at the coefficients of x in both the equations and then cross multiply them. That means the coefficient of x in equation 1 will be multiplied to the second equation and the coefficient of x in the second equation will be multiplied to the first equation, such or so that we can get the coefficients of x as same in both the equations. Once we get these coefficients as same, we can directly eliminate them by subtracting. So 66x minus 66x, this will be cancelled to 0. Right, so this is minus 54y plus 55y, that leads me to y, and this is minus 33 plus 24, that is minus 7 is equal to 0. Sorry, that is not minus 7, 6 plus 3, that is 9. Right, so that is 9 and hence y is equals to 9. So we get the solution of this equation as y equals to 9. Is it clear? Right, now what we are going to do is we are going to substitute this value of y in either of these two equations, that is 1 or 2. So substitute y equals to 9 in equation 1, we get is 11x minus 9 into 9 plus 4 equal to 0. So that is 11x minus 81 plus 4 equal to 0. Right, therefore 11x minus 77 equal to 0. Therefore what can you say, that 11x is equals to 77 and hence x is equals to 7, cancelling 11 on both the sides. Right, so we got the value of x as 7. This is not yet the solution. We just solved the equations and we got the value of x and y. Now the fraction is x upon y, that is 7 upon 9. This is our final solution, that we need to find out the fraction. So x upon y is equals to 7 upon 9 is the fraction. Now we got the fraction here, but we don't know that whether this is correct or not. We might have made some mistake anywhere in the solution. Right, so let us cross verify it, that the fraction here is 7 upon 9. If I add 2 to numerator and denominator, that will give me 9 upon 11. Yes or no? So the first condition is satisfied here, that if I add 2 to the numerator and denominator of the fraction, I shall get the fraction as 9 upon 11. Right, and if I add 3 to the numerator and denominator, then I shall get 10 upon 12, and that is in fact 5 upon 6. Right, so if I add 3 to the numerator and denominator, then also I am getting the fraction as 5 upon 6, and that is verified over there. So the fraction that we got here is correct. Right, so that is our required fraction. The fraction is 7 upon 9. Take a look over it. let us solve one more example here, that we are having a condition now, right? There are two friends, Nuri and Sonu, right? Now the first one says that 5 years ago Nuri was thrice as old as Sonu, thrice, 3 times. And 10 years later, that means after 10 years, Nuri will be twice as old as Sonu, right? Find their ages. That means find their present ages. We are having this condition given to you. So first of all, what we need to do? We need to make the equations and then we need to solve them, right? Let us try to make the equations here first of all. Let, what do we need to find out? The present ages. So let the present age of Nuri is or be, let the present age of Nuri be x years and that of Sonu be y years, right? So let the present age of Nuri be x years and let the present age of Sonu be y years. Now according to the given conditions, let us fit these variables over there and let us try to find out the equation. Therefore 5 years ago, that means 5 years before from today's age, right? From today's age we must go 5 years backwards. So before 5 years or 5 years ago, the age of Nuri, that was x minus 5 years and age of Sonu was y minus 5 years, right? Similarly, let me also find out the ages 10 years later, right? See, this 10 years later are not from 5 years ago, it is from the present condition. 10 years later, that means we are going to first come to the present condition and then we are going to move on to 10 years later. Don't move 10 years later from this condition, that will lead you to a wrong answer, right? So 10 years later, that means from the present condition we are going to move 10 years after. So age of Nuri that will be x plus 10 years and age of Sonu that will be y plus 10 years, right? So we got the ages of Nuri and Sonu before 5 years. We also got the ages of Nuri and Sonu after 10 years. Now let us fit them in the condition given. So according to the given condition, what can we say? That age of Nuri is thrice as age of Sonu before 5 years, right? So age of Nuri, that is x minus 5 years before 5 years, and age of Sonu is y minus 5 years before 5 years. So age of Nuri is thrice, that means 3 times the age of Sonu, that means x minus 5 equals to 3 into y minus 5. That will give me x minus 5 is equals to 3y minus 15. Taking this both on the other side, that will give me x minus 3y plus 10 is equal to 0. That is my first equation. Right? Is it clear, everyone? Now the second equation will give me, therefore again x plus 10, that is twice of y plus 10. Age of Nuri after 10 years is twice, 2 times, twice that means 2 times the age of Sonu after 10 years. That means 10 years later Nuri will be twice as old as Sonu. That means 10 years later, so the ages after 10 years is x plus 10 and y plus 10. So x plus 10 is equals to 2 into y plus 10. Okay, now let us try to solve it. Therefore x plus 10 is equals to 2y plus 20. Take this both terms on the left side, that will give me x minus 2y minus 10 is equals to 0, and that is my second equation. Is it clear, everyone? Now we got the equations 1 and 2. Now notice, friends, that here the coefficient of x in both the equations is same already. Yes or no? Yes. See, the coefficient of x here in the first equation is 1. The coefficient of x here in the second equation is 1. Right? So friends, we are not going to multiply by any real number here to either of the equations so as to make the coefficient same, because it is already same. So simply eliminate 1 and 2. That means eliminating equations 1 and 2, we get x minus 3y plus 10 equal to 0 and x minus 2y minus 10 equal to 0. Let us change the sign here, right? So that x and x will be cancelled. Minus 3 plus 2, that is minus y, plus 20 equal to 0, and hence we get y is equal to 20. Right? Y equals to 20. Now substitute y equals to 20 in either equation number 1 or 2. Let us put it in equation number 1. What do we get is, we get x minus 3 into 20 plus 10 equal to 0. Therefore x minus 60 plus 10 equal to 0. Therefore x minus 50 equal to 0, and hence x is equals to 50. Right? So we got the values of x and y. X is equals to 50 and y equals to 20. Therefore the present age of Nuri is 50 years and that of Sonu is 20 years. Right? Now let us try to see it here, that whether the conditions are being satisfied or not. So 5 years later from here, so we will get 5 years ago. 5 years ago, that means the present age is 50. So 5 years ago the age was 45, is equals to 5 years ago that of Sonu. That means present age is 20. So 5 years ago the age was 15. Right? Now to balance this equation, we need to multiply 3 to the age of Sonu. So that we have did it here. Check it. 45 equals to 3 into 15. And 10 years later, that means after 10 years the age will be 60 here, that of Nuri. Right? And the age of Sonu will be 30. So to balance this equation here, we need to multiply 2 to the age of Sonu. So 60 equals to 2 into 30. That is what we did here. X plus 10 equals to 2 into y plus 10. So the ages that we got here are correct. That means the present age of Nuri is 50 years and that of the Sonu is 20 years. Is it clear, friends? Okay, let us move further. So let me solve one more example, the last one of this method, then we shall move on to the third algebraic method, that is the cross multiplication method. Okay friends, so the last one of this kind is Meena went to a bank to withdraw went to a bank to withdraw rupees 2000. She asked the cashier to give the money in rupees 50 and rupees 100 notes only. She received a total of 25 notes. Right? So what we need to find out here is find the number of 50 rupees notes and 100 rupees notes. Right? Find the number of 50 rupees notes and 100 rupees notes. So first of all, let us say that we need to find out the number of notes here. So we are going to assume the variables for these both notes only, right? Let the number of 50 rupees notes be X and that of 100 rupees notes be Y. Right, let the number of 50 rupees notes be X and let the number of 100 rupees notes be Y. Therefore, according to given condition, she got 25 notes in all, right? She received a total of 25 notes. Therefore, X plus Y is equals to 25. That is my first equation, and the total amount that she withdrew is rupees 2000, right? Therefore 50x plus 100y, that is equals to 2000. That is the second equation. Is it clear or not? See how it is going. The total notes here are X and Y. That is 50 rupees notes are X and 100 rupees notes are Y. So the total notes X plus Y is equals to 25. Right? And then the next thing, the total amount that she withdrew is rupees 2000. That means if she had 50 rupees notes, then how much 50 rupees notes? Right, let me say 5. So 5 into 5, that is 250 rupees. Similarly 100, that means let me say 10. So 10 into 100, that is 1000 rupees. So 1000 plus the amount that she received for 50 rupees notes, the total should make equals to 2000. Right, so we got the equations here, X plus Y equals to 25 and 50x plus 100y is equals to 2000 rupees. Right, now to eliminate them, we need to multiply this equation number 1 by either 50 or 100. So multiplying equation 1 by 50 and eliminate. right? So first of all, if I multiply the equation number 1 by 50, I shall get 50x plus 50y is equals to 1250, right? And the second one, I shall get 50x plus 100y is equals to 2000. So subtracting this, what shall I get? This 50x is cancelled, minus 50y is equals to minus 750, right? And hence I shall get y is equals to minus 750 upon minus 50, 0 0 cancel, minus minus cancel, and that is 15, right? Therefore y is equals to 15. Is it clear? So we got the value of y as 15. Substitute y is equals to 15 in equation number 1. That will make my solution easier. So I am substituting it in equation number 1. You can also substitute this in equation number 2, right? That won't make any difference. So y equals to 15 in equation number 1. We get x plus 15 is equals to 25, and hence x is equals to 10, right? So Meena received 10 notes of rupees 50 and 15 notes of rupees 100, right? You can verify it. 10 plus 15 is 25, so the first equation is verified, and second equation 50 into 10, so that is 500, plus 100 into 15, that is 1500. So 500 plus 1500, that leads us to 2000. Is it clear, everyone, friends? So this is the solution to the given question, right? That she received 10 notes of 50 rupees and 15 notes of 100 rupees. So now we are going to move on to the third method of the algebraic solution, or third method of solving a pair of linear equation in two variables, that is the cross multiplication method. Cross multiplication, what do you mean by cross multiplication? Is to form to get the solution of the equations given to you simply by multiplying the coefficients of x, y and the constant term in a particular manner. So before solving this, let us take an example to understand how this cross multiplication works. So the third method is the cross multiplication method, right? The cross multiplication method. I am having an example here. The first one is 2x plus y is equal to 5 and 3x equals to 8. Note that, friends, this type of method, this type of sums, or the sums that are asked to be solved by cross multiplication method, has a particular format to write, right? This kind of sums are written in a particular format so that you can understand each and every step, that how it is going. And mind well that if you make a minor mistake of sign, that is either you converted plus to minus by mistake or minus to plus by mistake, then the whole answer is going to get wrong. And one more thing is that you will never be able to find out the mistake. What you are going to do is simply cut out that sum and again you are going to try it by yourself, right? So that will be too much time containing. That if we make a mistake here, then we are not going to get the mistake and we are not going to find out where we did the mistake. So mind well that you do it consciously. First of all, the very first step is to convert the given equations in their standard forms. Right, to convert the given equations in their standard form. So whether the equations are in standard form or not, that we need to know. Now, what is the standard form of a pair of linear equation in two variables? That is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. That means the right side of the equation after equal to there must be 0. That means if any of the numbers or any of the constant term are present on the right side, that must be taken on the left side. So again, continuing here, therefore this equations can be written as 2x plus y minus 5 equal to 0. That is our first equation. And 3x plus 2y minus 8 equal to 0. That is our second equation. Is it clear, friends? So this is our standard form now. Now let us write down the coefficients of x, y and the constant term in a tabular manner. So the coefficient of x here are 2 and 3, y are 1 and 2, and the constant terms are minus 5 and minus 8. Right? Is it clear, friends? So this is the way we have written here. Now we are going to cross multiply. Right? So first of all, let us write down the proper manner, x upon. Now see, friends, that whenever we are writing down the fraction of x. So below x you are not going to write down the coefficients of x. The remaining coefficients except the coefficients of x are to be written in the same manner as we have written in the previous step. That means below this x we are not going to write down. So hide it. This column is to be hidden here. Whatever the coefficients you see here, that is to be written here. So 1 minus 5, 2 minus 8. Right, see, the coefficients of x are not present here. The coefficients of x are 2 and 3. That is not written over here, right? Is equals to y upon. Now, under the coefficients of y, we are not going to write down this. Hide it here, that the coefficients of y are hidden. Right? So what you can see is 2, minus 5, 3 and 8. But we are not going to write it like this, 2 minus 5, 8. We are going to write it in the reverse manner. So beside minus 5, minus 8, there must be a column of minus 5, minus 8 only. And this 2 and 3 will be written over here. Right? Is it clear, friends? And is equals to 1. This 1 is for the constant term. Right? This 1 is for the constant term. So below this constant term, we are not going to write down this here. Is it clear or not? So I am hiding this column over here. After hiding this column, what can I see? 2, 1, 3 and 2. I will write it as it is 2, 3, 1 and 2. Yes or no? Okay. So right, in this way we are going to write down the coefficients here so as to multiply and get the solution. See, again I am repeating. Under the variable x, so in the denominator of x we are not having the coefficients of x. Under the coefficient of y or under the variable y, we are not having the coefficients of y, and in the denominator of the constant term we are not having the coefficients of the constant term here, right? So now what we are going to do is we are going to simply cross multiply them. Cross multiplying them in a manner. Right? How we are going to? First of all, we shall multiply this 1 to minus 8, and then we shall multiply this 5 minus 5 to 2. Similarly here minus 5 to 3 and 2 to 8. Here 2 into 2 and 1 into 3. Right? Therefore, x upon 1 into minus 8 is minus 8. Minus 5 into 2 is minus 10. We have multiplied this, but what to do here? Here we are going to subtract this both the multiplications, both the products. So 1 into minus 8 is minus 8, minus 5 into 2 is minus 10. Similarly, y upon minus 5 into 3 is minus 15. Minus 8 into 2 is minus 16, and again we are going to subtract them. Similarly, here I am going to write 2 into 2 is 4, minus 3 into 1 is 3. Is it clear, friends? So in the denominator, after multiplying the coefficients, we are going to subtract them. Mind well, we are going to subtract them. So here this will be, therefore, x upon minus 8 plus 10 is equals to y upon minus 15 plus 16 and is equals to 4 minus 3, 1. Right. Now simply comparing them. Comparing the variables to the constant terms, the constant term, what shall we get is 8 upon minus 8 plus 10 is 2 is equals to 1 upon 1 is 1, and similarly y upon 1 minus 15 plus 16 is 1 is equals to 1 upon 1 is 1. So we shall simply compare this first one to the last one and second one to the last one in order to find out the value of the variables x and y. Is it clear? So in order to find out the value of these variables, we are going to compare it with the constant term. So cross multiplying 2 into 1, that is x equals to 2, and 1 into 1, that is y equals to 1. So we got the solution to this pair of linear equations is x equals to 2 and y is equal to 1. Right. So the solution to this equations are x equals to 2 and y equals to 1. Is it clear, friends? So in this way we are going to cross multiply the coefficients and then we are going to find out the solutions. Right. One more example I am having with me is x minus 3y minus 7 is equal to 0 and 3x minus 3y minus 15 is equal to 0. Right, x minus 3y. Okay, so we are having this equations given to us here, that x minus 3y minus 7 equal to 0 and 3x minus 3y minus 15 equal to 0. Now note that, friends, the given equations are already in the standard form, that is x minus 3y minus 7, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. See the right side, the equal to 0, both the equations are equal to 0. So we don't require to convert it in the standard form here, right? So we are having these equations in the standard form already. Now what shall we do is, we shall take out the coefficients of x, y and the constant terms, right? So that is 1, 3, minus 3, minus 3, minus 7 and minus 15. Is it clear? So we are having these coefficients here. Note that now we just need to cross multiply them. Therefore x upon, what shall be done here? In under the variable x, we are not going to write down the coefficients of x, that is minus 3, minus 3, minus 7 and minus 15, right, is equals to y upon, we are not going to write down the coefficients of y. So first of all we shall write down the constant terms and then we shall write down the coefficients of x. Note that, friends, see the pairs adjacent are same. The coefficients of y, coefficients of the constant term, coefficients of the constant term, coefficient of x and y, right? So we are going to note that beside the coefficient of the constant terms, there must be the constant terms present, and beside the coefficients of x, we must have the coefficient of x. That means coefficient of y, constant term x and y. That means on both these sides we are having y, and in the center we are having the constant terms and the x, right? So you must note it like this, that whether what to do or what not to do, you must try to do it by yourself or you must find a way out by yourself. So that is 1, 3 and minus 3, minus 3. Now let us try to multiply this. Therefore x is equals to, first of all what we shall do is we shall multiply this and then we shall multiply this. So minus 15 into minus 3, that is 45, minus 7 minus 3 is 21, right, is equals to y upon minus 7 3, that is minus 21 minus 15, and is equals to the constant term 1 upon minus 3 into 1 minus 3 minus 9, right? Clear or not? Okay, so that is x upon 45 minus 21, that is 24, is equals to y upon minus 21 minus plus minus 21 plus 15, that is minus 6, is equals to 1 upon minus 3 plus 9, that is 6, right? Comparing the variables to the constant term, we get x by 24 is equals to 1 upon 6 and y by minus 6 is equals to 1 upon 6. Hence, we get the solution, that is x by 4 equal to 1 and y by minus 1 equal to 1, that is x upon 4. X is equals to 4 and y equals to minus 1. Right? So friends, the solution to this equations here given to us are x equals to 4 and y equals to minus 1. So in this way, we can find out the solutions of the given pair of linear equation in two variables by using the cross multiplication method.